Hi champ, welcome into the another amazing session, and in this session we are going to learn about the polynomials and its classification. So let us start champ. So in this class we are going to learn about the polynomials, the degree of the polynomials, that what should be the condition for any polynomials. Then we will see the classification of the polynomials and a very special polynomials with the zero polynomials. So let us start champ. So first of all, this word polynomials is the combination of two words. One is poly, one is nomial. The meaning of the poly is many and the meaning of the nomials is number of terms. So that means the meaning of the polynomial is what champ? Many terms, right? So we can say that polynomial is nothing but an algebraic expression where the power of the variables always a whole number. Let me show you with the help of some examples. Look at this example. In this, my variable is x, and in this expression, the power of the x is only the whole number, right? Whereas in this example, if I will take this x in the numerator, right? The power will be -3, and -3 is not the whole number, and that is why this is not the polynomial, whereas the first one is the polynomial. Very easy, champ, right? Very good. So now look at these examples. In the first one, the power of x, the power of the variable is a whole number, so it's a polynomial. Whereas in this one, power of the x is not whole number, not the variable. In this one, the x is in the denominator, and we cannot take this x separately in the numerator. That is why it's not the polynomial. In this one, the power of x is not the whole number, so not a polynomial. Power of x is -2, not a polynomial. Bacha, in this one, the power of x is 0.5, not a polynomial. Where in these two cases, the power of x, the power of variable is 1. So these two are the polynomial. So I hope now you know, champ, how to find that whether any algebraic expression is a polynomial or not, right? Very good. Okay. So now, champ, let's talk about that. What are the parameters? What are those parameters which defines any polynomial? So one is the variable, which generally gets defined by the alphabets x, y, z, and the second is the constant, which are nothing but just the numerical values. So the combination of the variables and the constant and the operations, we will get the polynomials. Okay, so now, champ, in these two examples, we can see in the first one, there is only one variable x. So this is known as the polynomial in one variable. Whereas this one consists three variables, x, y, z. That is why this is known as the polynomials in the three variables. It's very easy, right? Now, champ, let's move on to the next concept, which is the degree of the polynomial. So, champ, degree of the polynomial is nothing but the highest power of the variable in a particular polynomial. Okay, let's take one example. 3x squared plus 7x plus 8. So we can see that in this polynomial, the highest power of x is what? Is 2. Hence, the degree of this polynomial becomes 2 only. Very easy, right? Now let's see that what are those conditions which have to be in any polynomial. So, champ, if any polynomial is of the order n, this is the general form of the polynomial. And let's say if a polynomial of degree n, then an cannot be 0. That means the constant multiplied with x to the power n cannot be 0. All the numerical values, all the constant must be the real number, and my n, that means power, must be the whole number. So we can say the general expression for any polynomial in the single variable is this, right? Where these three conditions must be satisfied. Okay, now let's see how to represent any polynomial, champ. So, champ, we represent any polynomial by giving them some name like px, and this is called as the p of x. But we can also call it as fx, ax, gx, yx, whatever you want, but it should be only the small English letter. Okay, any polynomial can be defined by a small English letter with the variable x or whatever the variable the polynomial is in. Okay, very good. Okay, now champ. Now champ, let's see how to classify the polynomials. So champ, the polynomial can be classified on the basis of degree. That means, let's say I have the constant polynomial equal to constant. So degree will be 0 and the general form will be px equal to simple constant. Whereas in the case of linear polynomial, my degree will be 1. That is why the highest power of x will be 1 and the general form will be ax plus b. But remember the condition, my a cannot be 0, right? That we have seen in the condition, 3 conditions, right? The next one is quadratic. In the quadratic, degree is 2. That means the highest power of the variable will be 2 and the general form will be ax square plus bx plus c, where the coefficient of x square cannot be 0. Otherwise, my degree won't be 2, right? The next one, the cubic with the degree 3. And in the case of degree 3, my coefficient of the x to the power 3 cannot be 0 and the general form will be ax cube plus bx square plus cx plus d. Very easy. And the next one is a biquadratic. The quadratic has the degree 2, so the biquadratic has the degree 4, right? The highest power of x will be 4. So that is why the general form will be what? Ax to the power 4 plus bx cube plus cx square plus dx plus e, where the coefficient of x to the power 4 cannot be 0. Very simple, very ready concept, right? Excellent. Now champ, the polynomials also get classified on the basis of number of terms. Let's say I have a monomial. In the case of monomial, the number of terms will be 1 only, right? In the case of binomial, the number of terms will be 2. In the case of trinomial, the number of terms will be 3. Whereas in the case of polynomial, the number of terms will be greater than 3. That means if the number of terms are greater than 3, that is known as the polynomial. Okay? Very good. Okay, now champ, let's see the zero polynomial, a very special polynomial. So let's say champ, we have a polynomial equal to 0. Okay champ. So now champ, what do you think? What will be the degree of the zero polynomial? It will be 0, 1 or not defined. What do you think? So champ, the right answer is it is not defined. The degree of the zero polynomial is not defined. And why so? Because the 0, this 0 can be written as 0 into x to the power 1, 0 into x to the power 2, up to 0 into x to the power any whole number. That means the degree is not constant. In every different case, degree will be different, and that is why in the case of zero polynomial, my degree is not defined. It is clear? Very good. Excellent. Okay, champ. So now let's summarize our beautiful class. So champ, in this class, we have learned about the polynomial. That polynomial is an algebraic expression of this form with the 3 conditions. A n cannot be 0, right? All the coefficient of the variable must be the real number, and the n, which is the power, must be the whole number, right? And we have seen the degree of the polynomial is what? The highest power of the variable. After that, we have classified the polynomial on the basis of degree and the basis of number of terms, right? On the basis of degree, we can define by constant, linear, quadratic, and cubic with the degree of 0, 1, 2, 3 respectively. Whereas on the basis of number of terms, we can define the polynomial as monomial with 1 term, binomial with 2 terms, trinomial with 3 terms. And if the number of terms are greater than 3, then it is known as the simple polynomial. Okay, champ, so I hope you enjoy the class. So stay safe and be curious.